Hello and thanks for checking in to have a look at this video. I thought it was about time that I did an update to tell people exactly where I'm at with the 680 Pro. Almost 1 year now since the original build. For those of you who saw the original, you remember that the hex looked a little bit like this. And anyone who wants to see the original can check the link in the description. 1 year on, and the 680 now looks like this. Here are the main changes and some of the reasons for making them. Cosmetics first. The brightly coloured canopy had to go and was replaced with a carbon fibre lookalike, which is a lot more subtle. Next, and probably most significant, is the change in motors from the 2217 880 kVs to the Emax 3510 600 kV motors. This change, as well as a move to a 4-cell LiPo, has allowed me to increase the prop size to 13 inch by 5.5 pitch using carbon props. 13 inch diameter props is actually the maximum diameter that the 680 frame can accommodate. The motors and props were actually purchased from Radio C in the UK, a company who have so far provided me with an excellent service. The propellers are T-style direct mount, and because carbon props are easily chipped, I added quick mount system. Quick mount system was purchased from Unmanned Tech. These little accessories are anodized aluminium and are very high quality, and it lets you remove the props very quickly when you're making adjustments to the setup and for transportation. The original setup had 2 by 500 milliamp 3-cell batteries in parallel, which gave us a total of 10,000 milliamp hours. This enabled us to get a flight time of between 13 and 15 minutes, depending on the actual flying conditions and the flying style. The battery I'm now using is a Multistar 4S with a massive capacity of 16,000 milliamp hours. This battery is only marginally heavier than the 2x3S batteries installed earlier. The Multistar battery comes complete with XT90 connectors. Before actually making my motor prop battery combination, I did a lot of research and some actual bench tests. I documented these tests in the following charts, and I'll talk you through the findings that I got. First is the motor size calculator. Here you can see that the all-up weight is 3,724 grams or 3.7 kilograms. With a lift factor of 2.4 to make sure that there's plenty power, it requires a total thrust of almost 9 kilograms. That divided by the 6 motors gives you a thrust required for each motor of almost 1.5 kilograms. Of the 3 motors in the chart, you'll see that the original motor, the 2217 880 kV, only delivered 85% of the required thrust, which was a little bit down. On the other hand, the Emax MT3515 650 kV motor was delivering 188% of the required thrust, which was a little bit over the top and would probably reduce the duration of flight that I would get out of the battery. That's why I opted for the MT3510 660 kV motor, as that delivered an almost perfect 111% of the required thrust. Next we move on to the actual thrust tests that I carried out in the workshop And what I did here is I actually bought one motor first, fitted it to a thrust test bench and determined the thrust generated at full throttle and also the power required to achieve a thrust of 700 grams, which is the thrust required to enable the hexacopter to hover. You'll see from the highlighted area in the first part of the chart that the full thrust generated with the 13-inch by 5.5 pitch propeller was actually 1.9 kilograms. That's 1.9 kilograms for one motor, which is far in excess of anything required. Then the hover test, I gradually increased the speed of the motor until it measured a thrust of approximately 700 grams, or as near as I could get it in each case. And you can see from that the watts were extremely low at 84, and it was only drawing 5.16 amps. With that information, the next job was to determine some flight times, and again you can see the highlighted area that the 31 amps draw, which is the 5.16 times 6 for the 6 motors, and the next column along, using an 80% rule so that you don't deplete your battery, should give approximately 25 minutes of flight time. Add to that another 10% to cover some mixed flying, and I'm not talking about aggressive flying, bearing in mind that this is designed as a camera platform, but it would allow you to maneuver up and down, left and right, and gentle flying. This should give you around 17 minutes minimum flight time. Now we come to the gimbals, which have been the bane of my life. Over the last 12 months I've used 5 different types of gimbals, each with their own problems. I'll try and give you an overview here, which might help if you're thinking of buying a gimbal yourself. First was the H3 2D Zenmuse gimbal, which suffered from going into what was called limp mode. You'll see on this bit of video the gimbal drops over to one side for a while, then eventually picks itself up, but it kept doing that during flight. Next was the H3 3D from Zenmuse, which suffered from what's known as yaw snap. Again, I fly in a very windy place, and a lot of this was put down to the fact that the motors didn't quite have the power to keep the gimbal straight against the wind, and they kept dropping out. After that was the Walkera G3D, which was quite good apart from horrible jello because it's insufficiently damped. There's only 4 rubbers on it, extremely soft, and there's a lot of jello. After that was the DYS 3D gimbal. This gimbal has proved to be very good indeed. Very little jello. The only difficulty I have with this is the graphic user interface. Not always does the programming take first time when you send it to the gimbal, but this gimbal has excellent tilt and pan motion. In fact, it's the only gimbal that you can, or that I found, that you can do a full 360-degree turn. You have to be careful. It says in the instructions don't go round more than 2 or 3 times, because what you do is you tie the wires in knots. You can just see it going round here for a full 360. At the moment on this piece of video, it's actually attached to my flame wheel 450 just for a test flight. There are a few little judders in its movement, but that may have been down to the way I had it mounted, and I'll try and sort those out later. last but by no means least is the Feiyu-Tech G3 Ultra Aircraft 3-axis gimbal. This gimbal is extremely high quality build, certainly has the largest motors and performed extremely well. There was very little jello to be seen with the standard mounts, and the pan and tilt operation was extremely smooth. The only slight concern I have is with the way that the gimbal operates with the transmitter. You have to set it up in different modes, which requires flicking a switch to move from one mode to another. And when you're in the pan mode, the slider isn't proportional, it works on a speed basis, and as you move the slider further to one side or the other, the pan becomes faster or slower. Finding the center after that is very difficult, and the only way to do it is to switch modes back to another mode and it will automatically center. But from a performance point of view, this is my favorite so far. Just as a final comment, I now have the DYS 3D gimbal fitted to the Tarrot 680, and you can see its operation here. There are some issues with its centering or leveling properly, but I'll work on those. Hopefully I'll be able to get some video footage to post in the not too distant future. Unfortunately, the weather has been very poor. In fact, since November there's hardly been a handful of flying days. However, for the moment, I hope you found this update interesting. If you have any comments or questions, leave them below and I'll try and get back to you. Until next time, I would appreciate it if you would like and subscribe, and as always, thanks for watching.